Alrighty, so next lesson is imaginary numbers. All right, so before we left, we talked a little bit about how imaginary numbers come from the square root of negative numbers. Okay, so if I give you the square root of -4, we know that this actually doesn't exist. So instead, what mathematicians did is they developed a way to represent this part of the radical that's really the negative. So if I take the square root of -4 and I break it up into -1 times 4, okay, and then I break that apart even further. So now I have the square root of -1 times the square root of 4. Now the square root of 4 I can take, and this becomes I. So this is going to be I times 2. Okay, we know that there's a positive and a negative solution here as well, so I'm going to include that in a minute. So then my answer is going to be positive and negative 2I. Okay, so typically then rule of thumb becomes if we see a negative under the radical, okay, that is going to become an I, and then we are left with the perfect square or whatever number underneath that we can take the square root of. Okay, so I is defined as the square root of -1. Now we don't substitute that in. So when I get my answer over here and it says 2I, I don't write that as 2 times the square root of -1. Okay, the I is a symbol, kind of like pi, that we use to represent this numerical value. Okay, so what you've got to be able to know are powers of I. Okay, so as I start doing problems, I'm going to be given multiple powers of I, and I have to be able to reduce them down. Okay, so again, we know that I is the square root of -1, but we do not substitute that. Okay, so this is I to the first. I to the first is I. All right, so then if I have I squared, well, that means that I would have the square root of, oh, here, let me back up even further. Hold on. Okay, I squared is the same thing as I times I. Okay, I to the first times I to the first. Well, I to the first is the square root of -1, and I to the first is the square root of -1. So if I write this, then this is the square root of -1 squared, if I multiply those together. And when we take the square root of something being squared, they cancel out, and my answer is -1. Okay, so I squared is going to equal -1. So now, I'm going to move up here. I to the third, okay, well, I to the third could be broken down into I times I squared. Okay, so this would be I to the first times I squared using properties of exponents here. So remember, if I multiply two things like this, I'm adding the exponents to get the 3. Okay, well, I to the first is just I, but I squared is equal to -1. We proved that down here. Okay, so I can substitute that for -1, and now I get -I. Okay, so I to the third is equal to -I. All right. Now, I to the fourth. Okay, well, 4 can be broken up into 1 and 3 and 2 and 2. So I'm going to go ahead and use 2 and 2 for simplicity here. So I know that I to the fourth is really I squared times I squared. And I squared is equal to -1. So this is really -1 times -1. And that's going to equal +1. So I to the fourth is actually a real number. And I squared is a real number because I squared is equal to -1. Okay, so if I have powers of I that are multiples of 2 or multiples of 4, they're going to give me either -1 or 1 as my answers. Okay, so if I were to continue this pattern and I do I to the fifth, well, I to the fifth is going to be I to the fourth times I. So now that I know that I to the fourth is equal to 1, I'm going to use that as much as I possibly can because 1 is wonderful. When we multiply by 1, we get 1. We divide, it's easy. Okay, so we want to focus on this I to the fourth. This is going to be a key. Okay, so now this is going to become 1 times I, which is just I. And if I do I to the sixth, I can write this as I to the fourth times I squared. Well, I to the fourth is 1. I squared is -1, so this equals -1. And if I do I to the seventh, I have I to the fourth times I to the third. Again, you notice I'm using this I to the fourth over and over again, okay, because I know that that's equal to 1. Well, I to the fourth is 1, and I to the third is -I. That was on the previous board. So now this is equal to -I. And if I go to I to the eighth, now I have I to the fourth times I to the fourth, which is 1 times 1, which is 1. And hey, guess what? I'm back at that 1. And so this pattern is going to continue again. So if I do I to the ninth is going to be the same thing as I to the fifth. So I to the ninth is really I to the fifth, which is equal to I. And I to the 10th is going to be the same thing as I to the 6th. So that's going to equal -1. And I to the 11th is going to be the same thing as I to the 7th, which is -I. And when I get back to I to the 12th, I'm equal to 1. So this pattern is going to continue every fourth power of I. Okay, so realistically, what I really need to know then is just the first 4 powers of I. Okay, so this is what you need to know. We need to know I to the first is equal to I squared is equal to -1, I to the third is equal to I to the fourth is equal to 1. Okay, so this is the key right here. Okay, so now if I'm trying to simplify powers of I, here's where this is going to come into play. Okay, so here's our first example. So if I ask you, what is I to the 101st power equal to? Okay, well, I know that every 4 powers of I is going to give me 1. Okay, so what I want to know is in that 101, how many I to the fourths are there? Okay, so I take that power, 101, and I'm going to divide it by 4. Okay, so I'm just doing the math with the powers here. I want to know how many I to the fourths are in that power. So 4 goes into 10 2 times, that's 8. 4 goes into 21 5 times, that's 20, with a remainder of 1. Okay, so what that means is that I to the 101st power is the same thing as I to the fourth 25 times. Let me fix that. 25 times 1 I to the first left over. So that's my remainder. Okay, so these two numbers right here tell me I have I to the fourth 25 times, and then there's 1 left over. Well, what's I to the fourth equal to? I to the fourth is equal to 1. So this means I have 1 to the 25th power times I. Well, 1 to the 25th power is 1, and 1 times I is I. So I to the 101st power is actually the same thing as I to the first. Okay, let's do another one. So now, what is I to the 102nd power going to equal? So again, I want to know how many I to the fourths are in there, because I to the fourth is equal to 1. That's a real number. So I take 102, divide it by 4. Okay, 4 goes into 10 2 times. 4 goes into 22 5 times. And this time I have a remainder of 2. So if I write this is I to the fourth 25 times I squared. Well, I to the fourth is 1. I squared is -1. So 1 to the 25th power is 1 times -1 is -1. Okay, so when you're simplifying powers of I, divide by 4, and the remainder